Hello friends, welcome back to the bench. Thank you very much for joining me. As you can see, our patient is my trusted IR6500, which finally broke. But the damage is very easy, should be easy to repair, depending on what the actual cause is. How does it manifest? You turn on the fan switch and the fan doesn't turn on. What I suspect happened, I used it for a bit too long without the fan, because when I resolder or remove the socket or whatever I'm working on, I turn off the fan so it doesn't interfere. Then as soon as it's done, I lift the head or the top heater and I turn on the fan. Maybe move the heater out of the way and desolder or wick the board or what have you. But in my last repair, as you probably have seen, we had to keep it on 220. Well, actually we started with 195, then 200 to 205, 210, 215, 220. So this many cycles, yeah, it heated up very nicely. So it is very likely that the wires inside just melted. Maybe that's the problem. Or the fan itself broke because of the heat. The windings inside just overheated. So in that case, we have a replacement fan over here. So let's take a look. We need a hex key. Now mine is held by only 2 screws. Normally it's held by 4 screws, but mine only has 2. The reason is because I replaced the entire top heater, this entire assembly, and it's a little different in size. So I could only connect 2 screws, which is fine because this is not a mill, right? It doesn't need to be too stable. As long as it has 2 screws, it should be fine. So far, it hasn't been any issues. So let's open it first and see what's inside. And now I'm not even going to disconnect it because I want to test it. I want to see if the voltage is going to the fan. If it is, then the fan is broken. Or we'll see what the cables look like. Okay, looks like the cables are fine. I don't see any signs of melting. So let's see if we're gonna get a power over here. Well, they did suffer a little bit, of course, from all that heat. They're kind of crusty. Let's turn on the machine and see if we got the voltage. Because if there's no voltage, that's not gonna be good, because that would mean that we have a problem inside the machine. That'll be a pain. Let's turn on, and we should have, yeah, we got 1176. Okay, so we get voltage, which is good, because that means we only have to replace the fan. Now, how do we replace the fan? It's actually pretty easy because it's only 4 screws at the top. Let's see, same size, but I'm gonna make a little modification here. I think I'm gonna install the fan on the top so it's not inside the enclosure, and we'll see if that's gonna work. It looks like it's not gonna be as easy because these screws are much better. This is much better design. In the original one that I replaced, we had this, right? A screw with the bolt underneath and way oversized. These ones looks like screw in directly into the fan, which is great. It's a lot better design. It's a lot easier to disassemble it for sure. But I don't want this to happen again, and perhaps we could do some modifications to maybe open it on the side and have the fan blow from the side instead of blowing from the top. Now the reason for that would be so I can keep the fan throughout the procedure, keeping the top of the heater, top of the entire assembly cool, without interfering with the process. Now this is not going to be easy. Now let's do this. Let's connect a 12 volts to this fan and confirm that it's not going to spin. But I think at this point it is pretty certain that the fan got overheated basically. Just 11.2 volts, that would be enough. And black over here and red over here, and turn on, and oh crap, it is working. So just because my meter showed 11 point something volts, that could be a problem in the machine, the power delivery. That is bad news. Okay, I forgot which one is which now, so I'm gonna test both of them. I know one of them is working fine. Yeah, we gotta do something about that fan as well, because it's way too noisy. It really bothers me. This machine shouldn't be that. Okay, the fan is working now, but I think this is the replacement. But the other one was also working, so what is going on here? We definitely have plenty of melting over here, that's why this fan is there. Now what if we just put some insulation over there, inside? You know? Maybe. I mean, the fan is also supposed to cool down the heater, right? That's what I use it for as well. Once I'm done doing the procedure, I turn it on also to cool the heater, not only to cool the cables and stuff. Let's connect the other one and see if the other one also works now. And we still don't know why would it stop working before. This could be a problem of overheating inside the machine and there was no power delivery, right? It's possible. So this problem might come back. But the machine is designed to be working, you know, for a while, you know, few hours at least, right? Yeah, and this one is working now as well. So there are two explanations, two possibilities. One is that there is something wrong inside, and when it heats up, it stops delivering enough power to power on this little fan. This little fan is, it doesn't say, it's just 12 volts, but what would you think it was? 1 watt, quarter watts, half a watt? They are all quiet, right? No, this one is not. Yeah, this one has this one's good. Yeah, so we're gonna use this one. And I don't remember which one is which. Although they look, no, they are not the same, not exactly the same. The casing is a little bit different. But I can hear that one, the bearing is rattling. So it's definitely, I mean, you could, what you can do is you can just remove the sticker, right? That will expose the bearing. And you can put a little bit of WD-40 or machine oil or something like that to lubricate it and close the sticker. And that's how you can fix the rattling motor. But in this case, I think it's just loose. I don't feel much of a wobble on it. Well, maybe a little bit, but not much. But we're gonna use this one, and I would like to place it here, like this, at the very top, right? Not inside the enclosure, but rather on the top, and maybe even create a little distance, because we want the hot air to escape, because this fan also keeps the hot air inside when it's not doing its job. We could also place it upside down for the fan to just remove that hot air, but that whole hot air will be going through the fan. That's also not good. When it's placed like this, when it's pushing the air in, it's actually pushing in the cool air from outside. And I forgot the other possibility, and it looks like it could have been. So these are crimped cables. When they heat up, they might expand and the connection might be faulty. But it's less likely. Looking at it now, I would say this is less likely because there's a lot of surface contact between these. So even if the connection is poor, you know, we're pushing what, half a watt? Let's call it even a full watt of power. But there's no way this is 1 watt a fan. So even if you just touch it with the little bit, it'll start spinning, right? Even if the current is really, really low. And actually, we don't have to read that, we can just measure. I just realized that we can measure how much power it takes. It takes 0.7, 0.6 watts. I'm on 1120, let's do full 12 volts. 0.7 watts, right? So, yeah, below 1 watt, but I was expecting it to be more like a 1/4 watt. So I was off. So that's not a lot of power. That's really not a lot of power. So let's see what we can do here. Maybe the connection between these, that's also possible. Okay, so what I'm gonna do is I'm just gonna crimp them in place. I was thinking of soldering them on, but I think this might work a little better. We'll see once I start using it. I have one more board to work on today. Well, at least I wanted to work on it today, but the day just kind of disappeared on me. So I'm not sure. I do have to put it on the dryer for a while before I can do the procedure. I had a big delay because the humidity today was like crazy in the morning. Absolutely crazy. You know, Atlanta area is relatively humid, or the entire Georgia is rather a humid place, but today was unusually so. So it's really, you know, when the humidity is that high, you just walk outside and you're immediately drenched in sweat. Personally, I don't mind. I actually like that. But it's not good for the BGA work. The temperature needs to be low. Okay, and now we just need to put it, let me show you. So we just need to insulate it. This is called this. Yeah, we don't really need this protection over here, or at least I don't need it. I mean, I'm not saying it shouldn't be there, because yeah, you don't want to break the fins of the fan. There. So that's one screw, and I'm just gonna do 2 screws. It's and actually I'm gonna just do the ones that are closer to here, so that's gonna be easier to. I have 4 screws, but I lost one nut. That is somewhere still in the other heater where I recovered this fan from. And I can't, for the life of me, I cannot recover it. It got lodged somewhere inside and it won't come out. I can hear it rattling inside, but I can't get it out. Okay, so now it's sitting like this at the top. So now the only thing, we just need to insulate it because these cables are not insulated now. So let's grab some thermal shrink tube. Now I could probably just place it like this and run the machine and this would shrink by itself. But obviously we're not gonna do that. Do we need how much? Just a few millimeters should be fine. Now with working fan, you know, sometimes during the procedure I actually turn on the fan because I constantly just touch it here, right? Because the cables, they should be probably higher than they are here, because why are they so close to the heater? Escapes me. So when I touch it and I feel it like it's super hot, then I just turn on the heater, the fan for, you know, a few seconds just to kind of cool it down a little bit inside. And as you can see, the cables are really burnt. Now these do transmit a lot of power, so these need to be crimped properly, and looks like they are, or at least I hope they do. They are, because we have, oh, that doesn't look good. That doesn't look good at all. But what do we insulate it with? Well, the best way would be to insulate it with high temperature insulation. Just you can get those high temperature insulating tapes. It's basically like a regular tape, but it can withstand a lot higher temperatures. Alright, we got low voltage on this and we got low power on these, so I'm not too worried about it. It can just sit somewhere there. But I am worried about these. This could potentially now touch the enclosure, which would give me a solid shock. I prefer not to be shocked. If I just put regular electric tape like this, it's just gonna burn. They are pretty stiff. Part of the wire here is exposed as well, over here. So this is not safe. I mean, I'm the only one using it. I don't hire people, so, you know, it's kind of okay, right, in a way. That the only person that potentially can be hurt by this is me alone. So I don't mind having, you know, hazards like this. But on the other hand, I prefer not to be shocked by my own tools. You know, I do use a preheater that I built myself. And yeah, there are some wires here and there, but nothing as egregious as this. Let me look around the shop, see what I can find. Okay, let's use this. So this is high temperature insulation. As you can see, it also burns if exposed to too much heat, but it withstands a lot of heat. So this one's not too bad, but this one is awful. So let's see if we can disconnect this one, like so. Then let's cut a little piece of this, like so. Is it gonna fit? Oh, don't tell me it's not gonna fit. Okay, it will fit, but I need much smaller size. Or I can work a little bit around here. This is really tough. Really, really tough plastic because it has been heat treated. Okay, we got it. Now let's put another piece on the over here, like so. Now let's connect it again. Oh, it's poor connection. Okay, that's a little better. And now one over here and one over here, like this. Okay, it's not the best, but it's better than it was. At least now I won't get electrocuted. And this one should be good, but I want it in there, like so. And this one can be touching the, yeah, I don't want this one to be touching the case, the enclosure, but this one can, because now it's insulated relatively well. I mean, it's better if it's not touching, but it can. Okay, that should work. Now let's give it a test. So first I'm gonna reduce the temperature on the what do you call it, on the racks at the bottom. Now the fan is turning on. It's fanning. The fan is fanning. Okay, now let's turn on the heater. I don't know what program do I have. Oh, I guess, yeah, 160. All right, the heater is heating. Okay, perfect. So now let's turn on the fan and cool down the heater. See, just couple seconds and it's too hot to touch. These are because this is 450. Normally you get 400 heaters with these, but you can get 450. There are even 500 watt heaters of this size, but they're rare. I've seen it like once, but normally 450 looks to be pretty good. 450 works pretty well. I've done a lot of work on this. Alrighty, so now let's reassemble it and we're done. Okay, it's a lot easier when you have two people, but if you're alone, that's what I do. Put one screw over here and the second screw. Okay, we don't need the second screw at the moment because I lost it. One screw I would say is not quite enough. I would definitely like at least two. Because if you have only one, then this is gonna happen. So we need to find the second screw. Okay, found the second screw, and I also found the nut that I lost earlier. So we're good. So now let's tighten this one. Okay, so this one's tight, and tighten this one now. Unscrew there. Alright, it's working well. Let's give it one last test. Okay, the fan is fanning, the heater is heating. Good. Alright, let's keep the fan on now. See how it's fanning. Yeah, it's blowing pretty nicely, just like it did before, but now the heater, the fan is on the outside. Now, what was the problem? Why are both fans working now and it didn't work before? I guess we're gonna answer that question and in the next job, the next I assume CPU socket replacement, and we'll see. If it stops working again, then we have to disassemble the machine and see what's inside, how it is powered. That's gonna be a pain, but that's what we gotta do. Come to think of it, maybe if I do disassemble the entire machine, I'll just replace the bottom heater with 4 Elstein heaters. I have 8 in stock right now, so I gotta start doing something with them. Alrighty, quick repair of the IR6500. Very useful machine at an excellent low price. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.